So here we have a solenoid. As you can see here, it's a coil of wire that's going, coming out and going in and then coming out again. And each one of those wires is producing a magnetic field. And we're going to look at how those magnetic fields combine. So just going away from that, I want to just draw up a diagram here. Say if we've got a wire, and what's happening with this wire is it's coming in and it's going into the board, and it's coming out and going into the board, coming out, going into the board, going like this, and then it comes down like this, and we connect it to a battery like that. Okay, now so the wire is this one over here will actually be let's take that out there. That's goes into the board there and it comes out there like that. Alright, so your current is going in. You're going from positive to negative, so your current is in that direction. So the I is going like that, that, and then coming down like that. So you've got your current like that. Now, each one of these wires is producing a magnetic field. So what we want to do is I'm just going to go along here and just draw one circle just to indicate the direction of the magnetic field for each wire. That's when it's coming out of the and when it's going in. So let me have for the blue ones here, these are the ones where we are coming out here. These ones coming out. Now we know with our right hand, we put our thumb in the direction, we're going to have our curled fingers, we're going to have a magnetic field like that being formed. Like that. Okay. And then if I take my red ones here, it's going into the board over here, so there's a cross, cross, cross. We're going in, so thumb in the direction of the current, curled fingers in the direction of the magnetic field. We're going to have our magnetic field like that and like that. So in the inside, can you see that your magnetic fields are going in the same direction, that they're joining up together? And this magnifies the effects of the magnetic field. All those magnetic fields created by each coil are all joined together to form one big magnetic field. So they all combine together to form a magnetic field that goes straight through your coil, through your solenoid like this. And it's in this direction like that. So you get a magnetic field like that. And then on the outside what happens is it then turns around and it goes like that. Okay, so you get this combining effect of all the magnetic fields to create a magnet, a regular magnet. Now just going back to my PowerPoint where I've got a much better diagram there. So you get this situation over here. Now there's a rule to show the direction of the magnetic field, and it's called the right hand solenoid rule. Alright? And the rule how it works is you put for your fingers are in the direction of the current. Alright, fingers in the direction of the current, and the thumb in the direction of the magnetic field. Okay. Alright, so in this case over here, you've got your current going in and around like that. The thumb in the direction is in that direction over there. Okay, showing the direction of the magnetic field. Now, this would actually be your north pole of your magnet. This would be the south pole. So within a magnet, what happens is that within the magnet it goes from south to north, and outside the magnet it goes from north to south. Alright, so it curls around like this and goes like that. We have a similar situation with the Earth. So if I let me just find this one over here. Here's a regular bar magnet. Hope you can see it's not. You can. I'll put this app on the site if you like. We can show the planet Earth. Here's the planet Earth. You can't see it very well, but this over here, down here, is north, and this is south. Over here, this is south over there, and you actually get a magnetic field line when you show your fields. We get it that it comes down, so it goes out like this and around like that. You get your magnetic field lines going down like this at the south pole, which is actually which we call the north pole. Okay.
Why do we call North Pole south?
I don't know why. The northern hemisphere people decided they're at the north, and the southern hemisphere people didn't have enough voice to go against them. I don't know. Sorry?
Where is that electric current?
That's course. It's the actual electric currents are actually the molten metals within the planet itself, which are causing the magnetic fields. Okay. Now you've heard of the Aurora Lights. You've got charged particles that come from the sun, and they get attracted towards these magnetic fields, and they spin around these magnetic field lines and cause those lights. That's what causes those lights there.